Right, we're carrying on with equilibrium. Right, suggest why magnesium. Yep. Suggest why magnesium is not found as an element, but as a compound. And this means that it's going to be it's a very reactive element. That's it, simple as that. Right. Magnesium can be extracted from seawater by a multi-stage process. So calcium hydroxide reacts with magnesium chloride to form a precipitate of magnesium hydroxide. A precipitate, that tells you it'll be a solid then. Right. Magnesium hydroxide is filtered off and converted to magnesium chloride solution by reacting it with hydrochloric acid. Magnesium chloride solution is converted to into solid magnesium chloride. Into solid magnesium chloride. The solid magnesium chloride is melted and electrolyzed. Fair enough. Which stage involves a neutralization reaction? So where you've got hydrochloric acid, by reacting it with the magnesium hydroxide. So magnesium hydroxide is alkaline, hydrochloric acid is an acid. What makes something alkaline? It's the hydroxide ion. What makes something acidic is the hydrogen ion. This is alkali, this is acidic. So alkaline in nature, this is acidic in nature. This is an alkali and this is an acid. Right. A base and alkali are the same thing, but if you can dissolve it, if it's soluble in water, they call it an alkali. Okay, let's move on. Right, it'll be stage 2. Suggest the name of the product of the other product formed in stage 1. So you've got calcium hydroxide plus magnesium. Chloride gives magnesium hydroxide, and it'll be calcium chloride. Right. So this is what I can figure out from the reaction. So look, they've said calcium hydroxide, and you've got to know, right, calcium forms a 2+ ion, hydroxide is a -1 ion. I'm not interested in the signs, I'm just interested in the size. So this is a -1 or 1-. Because these two are opposite, what you do is you just cross over. So you end up with calcium hydroxide, but I cannot do this. This would be wrong. I'd have to put a bracket around here because I want 2 hydroxides. Just remember that. So it's going to be calcium calcium chloride, right? Or you can use the you can use that there. What happens to the ions in magnesium chloride during melting? Right, okay, they become mobile. Let me just move to the side of it. Right, they become mobile. Otherwise, you've got magnesium, and you've got, right, and they just vibrate around a fixed position, and they can't conduct electricity, so they become mobile when they're molten, or yeah, as they're melting or as they're melted. Right, again, you've got this. So you've got magnesium ion, you add 2 electrons. So remember this is where it gets confusing. This +2 tells you it has 2 electrons less. It is short of 2 electrons. It's not got an extra 2, it's got 2 less. That's why we are adding 2 electrons to give magnesium and the magnesium atom. So write half an equation at the positive electrode. Magnesium chloride. So it will be, you've got Cl minus. I'm going to do it this way. We end up with chlorine, and then we need 2 of these, because look, we've got 2 of these, so we need a 2 here. We can't stick a 2 here, we have to stick it at the front. So what we do is stick a 2 here. Now if you look, we've got 2 minuses, 2 electrons on this side. We need to balance the charges as well on this side. So all I would do is I would write plus 2 lots of electrons. Right. Manufacturing makes a batch of is this electrolysis? Right, what I'm going to do is just pause this for a second. I don't think we need to do this actually. We'll skip this, it's not part of electrolysis. Right, so right, so you've got magnesium oxide plus sulfuric acid gives magnesium sulfate plus water. Yeah, should we do this? We might as well. We might as well. Okay. So what you do is you mix the magnesium oxide with sulfuric acid. Keep adding sulfuric acid until in excess, till it stops dissolving. Then you filter off the excess magnesium oxide. Then you heat the filtrate, the solution filtrate in an evaporating basin using a tripod, gauze and Bunsen burner. Then what do you do? Then use a glass rod to check to see if what's it called, if point of heat to filtrate in evaporating basin. Right. Use a glass rod to check to see if the point of crystallization has been reached. Right, by checking to see that if you cool the rod, crystals form, you've reached that. Then you turn off the Bunsen burner and leave to crystallize. Or you can filter off the remaining solution, which is water and magnesium sulfate, and then put it onto a paper towel and tap it to dry, or leave in a warm place to dry. That's it, done. Right. This is what we're interested in. So electrons are flowing outside there, ions are flowing in here to carry the electricity. Right, okay. You've got cobalt ion and a chromate ion in cobalt 2 chromate. The pink color moves towards electrode A and the yellow color moves towards electrode B. Explain how the results show that the chromate ion is yellow. Right. The chromate ion is up here. Right. The chromate ion is CrO4 2 minus, so it will go towards a positive electrode. Right, and you're supposed to panic. So positive is anode. So this here is the anode, and this is the cathode. Right, what else is there? Explain how the results show that the chromate ion is yellow. So that goes, right, that's negative. It goes towards a positive. Yeah, there you go. Right, that's straightforward. So that's what we need to write. Chromate ions are negative and will be attracted to the positive electrode. Okay, good. Right, chromate ions in aqueous, that means it's to do with water. Converted into dichromate, two chromates, two chromiums. Right, we need to balance these. So we've got two minuses here, one plus there, two minuses here, that's neutral. We've got one hydrogen here, we've got two hydrogens here, we've got four oxygens here, we've got 7, 8, so I think we need a 2 here. We've got two hydrogens, so we're going to put a 2 here. We've got two chromiums, 1, 2. There, that's fine. We've got 8 oxygen, yeah, okay, it balances. And we don't need to put these two ones here. We've got that. Which solution is the source of hydrogen ions for this reaction? It'll be the HCl aqueous. Yep. So remember we said that is hydrochloric acid, and if it was HCl gas, it would be called hydrogen chloride. Okay. Okay. Part C, we're after this. An aqueous potassium chromate added to aqueous lead 2 nitrate, a bright yellow precipitate form. So they want the state symbols. So aqueous there, added to aqueous there, it gives aqueous and precipitate, so that will be solid. Right, now what we've got is of the insoluble. So right, what we want to do, we've got precipitate of the salt here. So what we do, first of all, we filter off the precipitate. So look, we've got our, right, that's our solution. And we've got precipitate here. So when we pour it through here, the precipitate is the salt we want. The filtrate goes through, we're interested in that bit. Right, so we filter the precipitate off. Then we wash it with, use the word deionized water. You can say distilled water, but deionized water. And then leave in a warm place to dry. There you go. That's it, done. So they've done the bit for you. We're just adding the last bit to get 3 easy marks, yeah? Right. Potassium chloride is very similar to sodium chloride. They have the same crystal structure, so 3D lattice, which can be electrolyzed. That's electrolysis to give similar products. So look, if you've got a positive ion here, you've got a negative one there. You've got a positive one there, negative. They alternate. Yeah, that's all it is. It's as simple as that. There you go, done. Right. You're supposed to panic. So positive is anode. So that there is the anode. It's an electrode, but because it's positive, it's called anode. This one is called a cathode. Done. Right? Chlorine is formed at the positive electrode. Describe a test. Okay. Easy. Test. What is test? What is the test for chlorine? That's a good question. It's turns damp litmus paper white or bleaches it. Turns damp. It doesn't matter red. Whether it's red, excuse me, whether it's red or blue. It bleaches. It turns damp red litmus paper white. Or what I would say is it turns damp red. That's fine. Or bleaches it. Bleaches. Yeah, same thing. So it turns damp red litmus paper white, or turns damp litmus paper red. Litmus, don't miss that word. Litmus paper white. Done. Next one. Hydrogen is formed at the negative electron. So I know hydrogen is formed. We can do the easy version. So this is how I would do it. I've got 2 hydrogens, so I need 2 ions, and then I've got 2 pluses, so I need to add 2 electrons onto this side. Right, the more complicated, sophisticated one is you've got 2 water molecules, 2 electrons. They give hydrogen gas plus 2 hydroxide ions. But this is the one that I know and I use. Right. The solution used contains phenolphthalein. Right, this is for the higher paper. Phenolphthalein. I say phthalein so I can spell it. Phenolphthalein. I think that's what I've heard some YouTube tutors say. Phenolphthalein. The solution negative goes pink. So the way I write it is I write acid, neutral, alkali. I can't see Pink Panther. So it's colorless here and here, and when it's alkali, it's pink. So if it's gone pink, that means it's alkali. What makes something alkali? The hydroxide ion. So the hydroxide ion is formed, so it is alkali or alkaline. Okay, half equation, Faraday. Okay, again, we don't need this anymore. So you've got a 0.0, you've got you've got a very small Faraday formed. So what you do is you divide it by 2 because you've got 2 of those, equals 0.0125 moles of chlorine formed. Again, we don't need this for this spec. And then what we do is calculate the volume of chlorine formed at room temperature and pressure. So we're saying 1 mole of any gas gives 24 decimeter cubed, and you've got to know 24 decimeter cubed is 24,000 centimeter cubed, or even milliliters. Right, but we've not got that. We've got 0.0125 moles. That's from here. Now, how many decimeter cubed will it be? So it'll be 24. Yeah, okay. So we can write 24,000 times the number of moles, which is 0.0125, and that should give 300 centimeter cubed. There you go. Right. What number? Okay, let's see if we can squeeze another one in. This apparatus can be used to investigate electrolysis. So you've got sodium chloride, you've got copper sulfate, you've got solid lead bromide. Solid means not conducting electricity. Right, name the particles that move through that. Right, okay, this is a good one, yeah. The particles that move through the connecting wires are electrons. What does the word inert mean? It means not chemically reactive. Right, why does it need to be, right, you heat it because lead to bromide needs to be molten so ions can flow. Okay. When sodium chloride is electrolyzed, 2 gases form. Right. How should we do this? Right. What we'll do is we'll do it. Right. I'm gonna panic. Positive is anode, so positive ion is called the positive electrode is called anode. Negative is cathode, so negative ion is called the cathode. So what's going to happen is sodium and hydrogen will be attracted here. I know sodium is more reactive, so it wants to stay like this. So what's going to happen here is hydrogen gas is going to be given there at the negative. It's hydrogen. Right, and then you've got them two are going to go over, right, and Does it say? Okay. It doesn't say that it's a dilute form. Unless they leave it long enough. So you're going to end up with oxygen and chlorine. Because both hydroxide and chlorine, chloride ions go there. That's going to form over, and then what happens is the hydroxide will break up to give oxygen, and the other hydrogen will go over to become H2O. So there's a equation for that. Right, just bear with me 1 second, I'll write that down. Right, we don't need to know that. Right, give half ionic equations. So you've got chlorine forming as a gas, and you've got a chloride ion. So we've got 2 of them, so we'll need 2 of them. And then we've got 2 extra electrons here, so we need to balance the charges on this side. It'll be plus 2 electrons here. Now if you look, 2 chlorines, 2 chlorides, 2 minuses, 2 minuses, so everything's hunky-dory. Right. This one's going to be an interesting one. So let's do hydrogen the way I know it. So I know I'm going to end up with hydrogen gas, so I've got 2 hydrogen ions. I've got 2 pluses. I've got 2 pluses here, so I'll need 2 pluses on this side. So you've got 2 pluses, so I'll need, I need to balance it out, so I'll need 2 minuses here, plus 2 electrons. Better on this side, on this side. Right. Now the oxygen's going to be an interesting one. This is one I always mess up on. So right, so we start off with water. That breaks up into oxygen and hydrogen twice. We're gonna have to balance it in a second. And some electrons, because this plus has to balance out, so we'll need some minuses on this side. So let's do that. So you've got 2 electrons so far, but the problem we've got is we've got 2 hydrogens, 2 oxygens, but only 1 there, so I need a 2 there. So I'll need 4. Let me just try that again. 4 hydrogens, so we'll need 4 electrons. So that's the full equation. This is a difficult one, but I think, it's quite important, this. Let's just try to make sense out of that. Yeah, okay. That's Faraday. You've used 0.04 Faradays. You don't need this for the new spec. We divided by 2 because we got 2 of them. We need 0.02 moles, and we want the mass, so we'll do 63.5 times 0.2, which equals 1.3 grams of copper. So we don't need that. Right, we'll call it quits there.